Okay, so we are supposed to be live. Yeah. So welcome everyone listening. This is the first Android meetup, Stockholm Android meetup that we're live streaming. We haven't done that before, so we hope this will go fine. Today, we're gonna have a talk by Nicola Corti, who is our latest organizer for the GG Android Stockholm. Welcome.
Ooh. Thanks.
Yeah. So we're starting now to see that everything is working. So if I'm gonna write a comment here in the chat and see if we get any. Okay, so yeah, so people are responding. It seems to work fine. Okay, great. So the topic of today is Kotlin keywords deep dive, where Nicola is going to do a deep dive into the keywords implementation, inline, infix, operator, tailrec, etc. So Nicola, tell us a little bit why you chose this topic and what are we going to learn?
Yeah. So first, thanks for introducing. Yeah, we're gonna see 4 keywords in Kotlin, specifically inline, infix, operator, and tailrec. I have the feeling that when you learn Kotlin, you learn the basic stuff like how to create a function, how to create a variable, val, var, this kind of stuff. Then there are like other kind of keywords that you might learn, or you might just skip it for now because you want to go directly into coding. But they're actually really powerful. And also, the more you learn Kotlin, the more you get in touch with the standard library and other libraries, you see that a lot of library developers actually uses those keywords. So yeah, we're gonna do a live coding. So I will show some code and I will present how we can use them, why they're important, and also we're gonna see some like implementation details, so how they work under the hood, and why you should consider using them.
Awesome. Looking forward to it. So just some practicalities while we're still waiting for everyone to join in. I said that I wrote that we will start at 17:45. We'll see how long we can keep this conversation going before we get boring. But yeah, so the practicalities is during the presentation, feel free to write questions. I will try to note them down. And at an appropriate time after Nicola is done, I will read them up and we will go through them. Also, I would like to remind everyone listening in that we are looking for other speakers for our meetup. So if you are interested, find us on the meetup.com. I will post a link in the comments or in the description later for this live stream. Unless you're already a member, just reach out to us and we'll set something up. Yeah. So what do you say? Should we get started? If you share your screen. Yeah. Is it too early, you think, or should we? Well,
I don't know. As you wish. We can definitely start. Yeah. Also, I want to remind to everyone that feel free to ask a question. That's also the first time that I deliver a talk in a live stream, and people that saw me speaking at conferences probably know that I'm really physical when I give a talk. Like my body speaks with me. And in this, I have to say that I don't feel 100% comfortable knowing that my body will not be live. We will see how it will work out. There will be lessons learned out of it. But yeah, and I would have also loved to give my first talk at the GDG Stockholm Android in person. But as you probably know, the situation is not really easy at the moment. But yeah, we're trying to keep everyone busy and sharing some information and knowledge. So we hope you guys you will enjoy that.
Yeah.
So there is a question actually that they asked me to talk about the scoping function. I will not cover that. just because I think they're probably worth their own talk. There is also a lot of religion and point of view behind scoping functions that I will not touch. I think this session that I'm about to deliver is about 35 minutes. Yeah, and I already had to compact as much as I could.
Yeah, I think so. So feel free to share your screen, and I will switch over here. Okay, so let's getting started here. Good luck, Nicola.
Okay, so do you see IntelliJ?
Yes, we'll see.
Awesome.
I see it.
Okay, so yeah, hi everyone again. Thank you for joining. I hope you love ASCII art, because there will be some. So as I said, like mandatory presentation slide, if we can call it like that. My name is Nicola Corti. I work as Android infrastructure engineer. That means that I build libraries and tools for other Android engineers. Yeah, and those are my contacts. So yeah, that's my website, and corti.com, and Twitter and GitHub. You can find me at cortinico, and this is my email. Feel free to reach out, ask me a question. I'm happy to support you. I also do a lot of open source. So if you have projects, ideas, you want to share something, drop me a message. Yeah, and as I said earlier, you're gonna walk through 4 keywords, 4 features of the Kotlin language. So the first one that we're gonna look is infix functions. So let's see what they are and what they allow us to do. So Kotlin allows the use of the infix notation for functions with the infix keyword. So I want to start presenting this keyword from examples from the Kotlin standard library. So if you develop with Kotlin, you definitely use the standard library, and there are a lot of functions over there that make use of this infix keyword. So you're gonna see some examples, and then afterwards you're gonna see how we can actually use it. Let's start from here. Okay, so here we have a for loop. It's a for loop that goes for e in from 0 to 10 and print stuff. So let's try to run it. Awesome. Okay, so little side note here, we have this notation 0.10. This is actually an operator that we will see afterwards. And you can actually command B and see there is actually a function. It's called range2, and creates a range between 0 and 10. So in computer science, when you do for loops, a lot of time you're iterating over arrays or lists, and you want to exclude the right boundaries. So you don't want to touch 10. You don't want to iterate over 10. So what you can do, like you could either write 9 here, but that's not elegant, as well as writing 10 minus 1. That will work. The problem is that also IntelliJ here tells you that, hey, probably you can replace this notation with until. So until is one infix function that basically will create a range. So returns an int range, and we'll do this -1 for you. And this is totally equivalent to calling until in this way. Yeah. But obviously, infix functions, they're more elegant because they allow this sort of infix notation. So let's say that now, instead of going from 0 to 10, you want to go in the reverse way. So from 10 to 0. So you might think that you can do something like this, like 10 until 0. If you try to run, you would see that actually nothing is printed. Yeah, and maybe you think about like, yeah, okay, so let's try to do this. 10.0, run again. Nothing is printed. So with this notation, IntelliJ is smart and tells us that this range is empty. Maybe you wanted to use down to. So down to is actually the solution that will work. We are printing numbers from 10 to 0. And I will not I will not deep dive so much into the implementation, but the reason why 10.0 doesn't work is because ranges are defined in Kotlin as a couple of numbers, and when the first number is bigger than the second, the range is defined as empty. While down to doesn't create a range, but creates an int progression that allows to go like in another way. And another infix function that is also really useful is if you want to go from 10 to 0, but skipping numbers. So for example, I want to do 10, 8, 6, and 4. So you can do it using another infix function. There is the step function. And it looks like that, 10, 8, 6, 4, 2. And as I said before, this is totally equivalent to this. Dot step 2. Okay, so let's continue. This one. We have two lists. The first is Daft Punk, harder, better, faster, stronger. And the second one is David Guetta, better when you're gone. So let's say that you want to calculate which items are shared between those two. So you want the intersection. So you could do it with 2 for loops. Yeah, but there are functions from the standard library that are more elegant and easier to use. So you can do Daft Punk intersect David Guetta and print. Great. So in the standard library, there are a lot of infix functions for manipulating sets and collections. So as there is intersect, there is also union. And you can do like that and create another list out of the result. And you can chain them. So let's continue this. So we have a variable called species with a list of pair. So those are lists of species of Star Wars with their own planet. And this works fine. We have this list. You can actually use a more elegant way to create those pairs, and is using the to function. So you will do this. Yeah. So this to function is actually an extension function defined on a generic type that allows to create a pair. So in this case, if you try to print this, species, we will see that we have our species printed. So maybe you want to be a little bit, and you don't want to use a list of pair of string, but you want to create your own type. So for example, you will create a data class, and you will call it species. And we'll have a name, there is a string, and we'll have origin, there is also a string. Those should not be pair anymore, they should be species. So what you can do, you can create a function that allows you to create a species. So for example, you can create an extension function on string called from, with a variable that we call origin string, and this will return this of this and origin. Okay, so now instead of using to, we can use from. So in this case, IntelliJ is sort of smart and understand that we are trying to create sort of an infix notation, but we haven't used the infix modifier on our function. So it actually suggests us to do it. And this is like our first simple infix function on string. So this applies on string and uses the word from and accepts another string, and we'll create a instance of a species. Let's continue. I think I have a print line here that I haven't removed. Yeah. Okay, so now let's create an infix function. We actually already created one, but let's recap this. So to create an infix function, you need to fulfill 3 requirements. So those are mandatory. Let's see what they are. First, the function should be a member function or an extension function. So previously, I presented the from function. There was an extension function on string. So that was something that could be an infix function. But if we try to make this function an infix function, it will not work, because we'll say that this is not a member function or an extension function. So what you can do, you can create your function and create your class and make this function inside the class. And in this case, it will compile, it will work. So that's the first requirement, member function or extension function. So not top level function, they will not work. So they must have a single parameter. So here we have a function called add and multiply number with 2 parameters, sum with integer and multiply with integer. So if we try to make this one infix function, this will not work. Again, because there are 2 parameters. The nature of this infix notation is that it's like a word placed between 2 other operand. So if in this case there are 3, because there is the receiver and the 2 parameters. So to make this code compile, you need to remove one of the 2 parameters. So single parameter, and then still on parameters, the parameter should must not accept variable number of arguments and must have no default value. So in this case, we have add numbers function that accepts a var arg. So you could add as many number as you want. So if you try to do to make this an infix function, it will not work. This will not compile. So you need to remove this var arg. There should be necessarily one number. And also, if you provide a default value like this will also not work, because if there is a default value, it means that you can omit this parameter when you call this function, and this doesn't work well with the infix notation. Okay, so let's make a simple example. Last example. So we have a playlist. A class playlist that contains a property called songs, and there is a mutable list of string. And then we have a function that is called add song. So there is a string. So I think I have another main up here that I need to remove, otherwise I will not be able to print. Yeah. So let's try to create a simple playlist. So my best playlist. Okay, and we put inside a song. So I can call add song, and I can add another song. So this one. And now I can try to print my best dot songs. Okay. So I want to make this this function as an infix function. So I could remove this. And IntelliJ tells us, hey, yeah, if you want to achieve this syntax, you need to add the infix modifier, and this will work. So we'll keep on working. If I want to chain these calls, as I was doing before with the intersect and union, so ideally I want to add multiple songs, like this. Now you can't. Why you can't? Because this add song function has a return type of unit. So you're trying to call add song on unit that is not defined. So what you can do instead is return a playlist here. And this will become, it's not read anymore, but this function is read because you're not returning anything. So what you can do here is actually use the apply function. The apply function will run the block and return the value. So in this case, you can add song multiple times and chain these infix functions. and you will have like a more elegant code. That's obviously something that you need to consider based on your code and what you're trying to achieve. But yeah, that's all on infix functions. I don't know, Eric, if there are questions, or I can continue.
I don't think there's any questions at the moment so far. So please go ahead.
Okay. Okay. So the second topic that we're gonna cover is operators and operators overloading. And this is really funny. So Kotlin has this nice feature that is called operator overloading. It allows us to provide implementation for a predefined set of operators on our types. Predefined set of operators. So they have a fixed symbolic representation, like plus or asterisk. And to implement them, you need to provide a member function or an extension function with a fixed name. This is extremely important because the name of those functions needs to be it's fixed. So the compiler expects a specific name. You can't use your arbitrary name. And then functions that overload operators need to be marked with the operator modifier. So now I'm gonna work through all the operators that are available. There are a lot of them, and some of them are really interesting to see, actually. Just one little disclaimer: pay attention when you play with operators, and make sure that you have an agreement on your code base on what's the semantic behind them, because you can go really wild. And if I see something plus something else as a developer, I expect that you're sort of merging or doing some arithmetical sum operation between those two operands. With operator overload, you can actually completely screw up your code. So make sure you use them wisely. So first, unary operators. So here we have a data class, song, with a title, there is a string, and a duration, there is an integer, and as a default of 0. And we're gonna define the first operator using the operator keyword. So this is the unary plus operator, and it's the operator that gets invoked when you do something like that. Plus and the name of your operand, the variable name. So what we do here, we return the absolute value of the duration. As there is the unary plus, there is also the unary minus. And yeah, you can just write unary minus. So IntelliJ is really smart in this in the autocompletion, because once you start typing operator in front of the line, it will show you only functions that are valid operator names. So in this case, we want unary minus. And a side note, on the right, you also see the symbol there is connected to that function. So in this case, unary minus is obviously the function that is invoked when there is a minus. So what I can do here, I can return abs of this dot duration and get the negative, for example. Yeah. And I can create a new song. And print minus song. And I have minus 42. So there is actually another unary operator. There is the not operator. So, and this is the operator that gets invoked when you do this. Use the bang in front of your variable. So one little thing, and this is sort of connected to what I mentioned before. Here you see that I have int, and boolean, because I'm using the minus, the plus, and this is this symbol reminds a logical not operator, but nothing prevents you from returning a string here. And you can do stuff like that. So this is valid. You're actually calling a function that is called through this symbol and returns a string. So here, like, as I said before, pay attention, because if me as a developer, I see this code, not song, I expect that the song is sort of a Boolean or something that computes a Boolean value and you're negating it. Well, this is not what is actually happening, because you're printing asterisks. So yeah, just pay attention. Let's go ahead. Yeah, the next operator is the increments. So we have a playlist with songs. There is an integer, and using the operator keyword, we can define this function called inc, and we can do this songs plus plus. So this specific operator inc requires that you return the same type as the receiver. So in this case, this needs to return a playlist, and then you need to return it. So as before, you can use the apply. So you can actually do this. And this is the operator that is executed when you use the plus plus operator. So I have my playlist that is, yeah, then I can do my playlist plus plus, and then I can print my playlist.songs. So here it complains because this should be a var. Let's try to run. Okay, 43. So the compiler here is marked and respects if you're using plus plus before or after or before. So it will actually either return the receiver type and then execute the operator, or vice versa. And as there is the inc operator that allows you to connect to the plus plus symbol, there is also the dec. So you can copy this and provide the dec. And this is what will be invoked when you do minus minus. Okay, so let's continue. Binary operators. So binary operators are the one that you probably see the most. So plus, minus. This, for example, is the plus. So this is what is invoked when you do like plus like that. You can have the minus. So the minus is pretty straightforward. So it's just like minus. Just make sure what you do inside is valid. And there are a lot of binary operators. So let's see them. Those times, div, ram, and range 2. So times is the multiplication, or this times symbol. Div is the division. Ram is the modulo. There is actually an older operator that is called mod. This is deprecated. I think it was deprecated in Kotlin 1.1 or so. So IntelliJ will prevent you from using this. But so you know, so if you expect to use the module operator, you'll probably start typing for mod. You need to use the ram, in fact. And then there is the range 2. The range 2 is the one we saw before with 0.10. But you can actually have your custom ranges or your custom range 2 operator. So you can have your custom type, and you can define this dot dot. So let's say that you have a band, you have 2 bands, and you have band 1 dot dot band 2, and this will return, I don't know, a list of string whatsoever. So again, it doesn't need to return a range. Is up to you on the return type for this operator. So another really interesting operator is the contains or the in. So the contains is really similar to the contains function and to the contains function that you have in Java on collections, and is invoked with the in. So for example, here we have an album that contains a list of songs again, and we defined this contains function. This must return a Boolean. So as you see, a lot of the times we delegate the behavior of our operator to another operator. So in this case, we define in on album as in on one of my property. So in this case, we have an album, the dark side of the moon, and we want to see if a song is inside. So I can check if a song time is in the dark side of the moon. True, and hello, it's probably not correct. This is really convenient. I think that a lot of times when you work with collections, custom collections, you want to check if an instance is contained in the collection or not. So I found it really useful, and it's also really elegant to see in the code. Let's continue, and there is the indexed access operator, so the get and the set. This allows us to access our collections. So in this case, I can get the first song of the album, or I can do stuff like dark side of the moon of 1 equal blah, blah, blah. So this syntax will invoke the get, while this syntax will invoke the set. So the power of this get and set is that this allows us to redefine the ordering. For example, on albums, we want to use the natural ordering. So I maybe want to say that when I say the dark side of the moon of 1, I want the first song, there is Speak to Me and not Breathe. That is actually the second. So inside the get, I can do stuff like this one. And this will work. You can also have indexed operators with more than one parameter. Like in this case, I can have a get on album with 2 parameters of type int and return this of position to this of position 2. So I will return a pair of 2 songs. And how do I call it? Like this. So I want the first and the second, or this is up to you. You can also go wild and do stuff like that. In this case, this doesn't work because you will need to specify a get for int ranges, while we just specify a get for 2 integer. So let's see what it prints. It prints this couple. Okay, so the invoke operators. So the invoke operator is the one that is invoked when you invoke something. So you use these 2 parentheses. So in the case of an album, this might sound stupid, but you actually happen to use this invoke a lot of times when you have like custom DSLs. Let's see what invoking an album could mean. Like, let's say that it could mean, I don't know, playing an album. So what you can do is like print playing this awesome album, and then you will do these dot songs for each, and you will print all of them. So how do you use it? In the main, then you don't need the print line anymore, and you will do like that. So you will invoke this instance, and it will actually work. So we'll print everything. Again, this can be confusing because sometimes invoking a variable might sound really awkward because generally when you see these 2 parentheses, you expect like a function, but there are cases where this could make sense. So another family of operator is the augmented assignment. So like the plus assign, and this is the operator that is invoked when you do like this, plus equal. And there are actually a lot of them. They basically mirror all the binary operators. So you will have a minus assign, times assign, a div assign, and a rem assign with those syntax. So One little note on the augmented assignment. So with the augmented assignment, you can do stuff like this. So you can add a song in this way. And then you can actually invoke the instance and see what it prints. So you see that there is a new song here, and this works fine. What you can't do, like here I had to invoke it, or what I would have loved to do is probably doing something like that. Like do the plus sign and then print it. You actually can't. You can't because this is an assignment. So these assignments in Kotlin are not expressions, and you can't you can't print the value. Like this will be a unit, so you can't do it. You need to call the plus sign, and then you need to print the result. So let's continue. Comparing operators. So no. So the comparing operators is really similar to the comparable interface in Java. So you need to provide a compare to function that returns an integer, and the contract is the same. Like you need to provide 0 if the elements are like they're the same in their order, or -1 or +1. So for example, to compare two songs, you can return this dot duration minus other dot duration. And this compare to is the operator that will be invoked when you use less greater than operators. So you can have like stuff like that. And then you can print if song 1 is less than song 2. Yeah, it is. So again, this is also really handy. Then we have the bitwise operators. So I added them here, but they're actually not operators. And this is really interesting to know in a way that Kotlin doesn't have bitwise operators. So in Java, you will have like bit shifts or bitwise and or. Here you don't. So what you have instead are those functions, those infix functions. They are making the bit magic, but you don't have symbols like this to like just an ampersand to do like a bitwise and. You don't. There is actually a keep that I invite people to see. It's number 142 that contains a proposal on bitwise operators, but so far hasn't been implemented yet. So yeah, that's one thing that Kotlin doesn't have. Yeah, and the last operator that I want to present is the one about identity checks. And this is sort of interesting because I found that a lot of people are not aware of the fact that Kotlin have Kotlin has two identity checks operator. So here we have two variables called it's alive 1 and it's alive 2. And you can do it's alive 1 equal it's alive 2, or you can do it's alive 1 equal it's alive 2 and print it. Let me do print line because, yeah, nice. So those are equals. I assume this equal operator is to check if two items are equals. So yeah, the text is the same. So true. This feels okay. Feels natural. But now let's go down. Here we have two lists, quote 1 and quote 2, and they contains a list with 2 strings, and they're the same. It's alive. It's alive. You can check. They are. It's like one the copy of the other. And then let's do the same. Equal equal or equal equal equal. And let's print this. So the first returns true, and the second returns false. Why? So if I will change this, if I will change quote 2 to be quote 1, they will both return true. And here, this sort of explains why now they're both true. So these equals, 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 as well as this operator, they perform a reference check. So they check if the memory address that is inside this variable is the same. So if they point to the same object. This is instead another operator that you can redefine. Specifically, if you search inside abstract list, you will see that this is defined, and it actually performs these ordered equals. So it goes inside the list and checks that they are ordered and they are equals. So in Kotlin, you can't redefine these operator, the triple equals and these operators. They can't be redefined, and they check. They perform only that. They check if the memory is the same, the memory address is the same. While you can redefine this other operator. Let's see how. So you have this syntax. So A equal equal B. So this gets converted into this other stuff. That sounds a bit weird at the beginning, but it's nothing more than a safe call of equals, the function that you can define with B. And if this returns null, so with the Elvis operator, we check if the second operand is a reference to null. Think about it. Sounds a bit complex at the beginning, but this is actually the correct way to do that. And to define this operator, you need to use equals, and necessarily the parameter needs to be a nullable any. Like if you remove this, IntelliJ will tell you that, hey, you're trying to use an operator on something that is not what I can accept. It should be equals, and the parameter should be a nullable any. And here you can do whatever you want. Like here you can return false. Let's say. So let's try to use it. I think I have a main function over here that I need to remove. So we have a podcast with a name and a string. Okay, so I have 2 podcasts with the same test, and now I try to do the quality check on those 2, and also this one. So now there is no audience, so people will not tell me. But now what I would expect. So I expect to see false, false here. Sorry, not this should, yeah. This should be podcast. So this. Yeah, I expect to see false, false. Why? So let's start with this. This is false because those 2 refer to 2 different objects. So I'm creating 2 instances of a podcast. If I will actually do this, this will be false and true. So this is the reference check that we saw before. While this, and if you see, like if you stay with a cursor in the middle, you see that this equals word here gets highlighted because IntelliJ sort of smarts and tells you, hey, you're calling this. And this returns false. So again, here what you should do, you should delegate. So in this case, you have other, there is nullable any, so you will do if other is a podcast, then you will return name equal other dot name. Otherwise, return false. And in this case, it will return true. So this is like a correct implementation of a equals. Yeah, and this is all for operators. Again, Eric, if there are questions on operators, I'm happy to answer them now. Otherwise, this was like the biggest topic. The other two are a bit smaller.
I think we haven't got any more questions. So
okay.
I think you're super good at explaining this. So let's move on to the next one.
Okay, so other two keywords that we're gonna see. So the first one, and it's actually really short, is the tailrec. I really like it, and now we will see why. So Kotlin supports a style of functional programming known as tail recursion. You just need to use the tailrec modifier on your function to use it. So tail recursion is something that I personally studied at university. So if you don't have a computer science academic background, you might have never seen that. It feels really academic, but actually it's first, not really complicated to explain, and second, is also really powerful. And let's see how. So to fully understand tail recursion, you need to know that when you work with recursive functions, you might have problems. Specifically, one is the Stack Overflow problem. So you might call your recursive function a number of times that is easily exponential. So, and that can blow you up really easily. So tail recursion is a way to mitigate this. But let's start with an example. So to be eligible for the tailrec modifier, a function must call itself as the last operation it performs. So let's see what this all tailrec stuff means. So we have the factorial function. It takes as input parameter called n. There is an integer and returns an integer. And in this case, I just define it as 1. This is obviously wrong, so we are gonna define it. So I really like writing recursive functions with Kotlin because you can use when. And if you check Wikipedia, a lot of functions are defined like recursive functions are defined in this way, where you have like a series of cases and you define for all of them what the function should do. So in the recursive function, you specifically have 2 cases. So the base case, there is when you ask the factorial of 0, there is 1. And in all the other cases, I don't need this, you call n times factorial of n minus 1. Fantastic. So yeah, the compiler is not happy because I need to return this. Correct. If you want to be also a little bit more elegant, you can actually write this as an expression, and you can test it. So factorial of 5. Let's see. 120. So this sort of works. So this is a recursive function, obviously, because recursive means that it calls itself. So we have a factorial call inside. And if we don't write it properly, like if I don't do this -1, this will never finish, and it's bad. So pay attention when you play with recursive functions. But so let's try to use the tailrec. So here everything is yellow. And IntelliJ tells us that a function is marked as tail recursive, but no tail calls are found. So what is the problem here? The problem is that here I'm returning 1, and here I'm returning n times a recursive function. So if I will remove this n times, IntelliJ will actually be happy. So that's the culprit, but the function doesn't work anymore. So the factorial of 5 is not 1, it's 120. So I need to fix it somehow. Let's go back to this. So there is a tool inside IntelliJ. There is the bytecode, the compiler, and it's really powerful. And I invite you to use it. And now we're going to use it to see how this code looks like. Bytecode. The present is decompiled here. So we have our main function, and inside we call factorial, and this is our factorial function. And we see that we call again ourselves. So the tailrec function, the tailrec keyword here, if we try to remove this n star, we'll make this magic. So if we go back, so now there is no yellow anymore, we go back. So this function has been converted into a while loop. So if you see inside, you don't need to understand all the details of this. This is decompiled Java, so it's sort of awkward to see. But this is the equivalent code, and we see that we have a while true and stuff inside. And there is no recursive call, so this can't go on Stack Overflow. And this is really powerful. It's like the compiler is sort of doing this strong optimization. But again, this doesn't work because the factorial is computed wrongly. So, and here we go back to, it's sort of like a computer science topic. So some functions by their nature can be rewritten as tail recursive. So tail recursive means that the function either return a base case, like in this case, like you immediately say what is the output of or the function, or you do another call at the same function without doing any other operations, like doing multiplication, calculations, or even like doing another call like this to the same function will not be valid for tail recursive. So let's try to rewrite this factorial function in a way that allows us to be tail recursive and also compute the real factorial of 5 and all the other numbers. So yeah, let's go here. Oh. Let's go here, and we have this other function. We call it factorial tail. It starts as before. We have one parameter, n is an integer, returns an integer, is initially defined as 1, and let's start defining it. So what we know is this. This is the skeleton. So the function should follow this. I can't do other operation here, and here I need to return something. So to make this factorial tail recursive function, I need to have an extra parameter. This is generally the way to make functions being tail recursive. So I need like a partial. There's an integer, and I can also already initialize it to 1. So in the case when it's 0, I will return the partial. And in the factorial tail, like in the recursive call, now I need to pass 2 parameters. So the n, and I can decrease it. And I can carry over this partial calculation. Okay, so now let's try to first prove it that it works. Okay, so we have factorial tail and factorial. Let's try to run both. Okay, so now this factorial tail, if I can add the tailrec keyword here, and this is not yellow, it's correct, and now I can see what the bytecode looks like. So here we have the old factorial that, as we can see, is still calling itself, and here we have the factorial tail. This is the optimized version, and this is a while true with cases inside. And so this is basically all around the tailrec. One little side note. So tailrec is a little bit different than public or private, or I like to think of the other keywords as semantic keywords, like they specify if the function should override other stuff, while tailrec is more like it's like a compiler annotation. It sort of tells the compiler, hey, this optimize this, please. And this is also the reason why it will not fail if the function is not tail recursive. It will just tell you that, hey, this is ignored, basically. That's all on tail recursion. And then I'm here for the last topic. There is inline functions, unless there are questions. Seems like not. Okay, so inline functions. This is the last section that we're gonna see. And yeah, let's see what they're all about. So when you use high-order functions in Kotlin, you end up with runtime penalties. So each function is an object, and it captures a closure. So the variables, they are accessed in the body of that that function. So if you do a lot of high-order programming, high-order function, you can mitigate the impact of this with the inline function modifier. So now we're going to see an example of what is the impact and how the inline mitigates that. So let's go here. Function main, print line, do something. Okay, and then we have this do on debug. So that accepts a lambda, like a block that has no parameter and returns a unit. So we want to use it, do on debug, and we want to, I don't know, print like a shrug. Okay. And it doesn't work because I haven't said anything about do on debug, what should be done. So what do? Stuff like that. We just invoke the block. Actually, this is do on debug. So on Android, you will check build config.debug. Here, I don't have the Android environment set up, and I don't want to run an Android app just to test this simple code. So we're gonna use an environment variable. So we're gonna check if the debug environment variable is set, and if the variable is set, we're gonna call the block. Also, my indentation is going wide today. I don't know why. So yeah, this is just like a util function. Like, let's say that you want to say do on debug block. So you have a nice way to say like if debug do something. So let's see if it works. It doesn't print because the environment variable is not set. So let's set it here. I can create a new one. True. Okay, so you see it printed correctly. Let's see what the bytecode of this looks like. So this is the main. You have the do something, and then we print it. And then we have do on debug. So do on debug accepts a function 0. Function 0 is defined in this file and represents a function that takes 0 argument. So you need to create an instance. So especially when you do a lot of high-order programming, you have a lot of these small lambdas with code inside, and then you will create an object for all of them. So you can mitigate this by saying inline in front of the function. And let's see what that will look like. So if we go now in the main, we see that we have the do something, we print it, and then this is the code. So there is no function 0 anymore. It's just copied over. And this is really great because we don't do memory allocation for that. We just copy and paste the code, basically. Copy and pasting the code as is pros and cons. First, if the inline function is long, then you're gonna copy over code. And that can be bad. So pay attention to that. But also there are some limitations or things that you need to consider. And that's also why Kotlin offers 2 other keywords related to the inline functions. There is the no inline and the cross inline. So those are 2 keywords that I always have the feeling that people have no idea what they do. And they find them in the Kotlin standard library and they say like, oh yeah, this is cross inline. I don't know what exactly it does. So let's try to explain them with a simple example with this do on debug function. So far here, everything should be clear. Let's say that now you want to provide a logger. So a logger will be a function that takes a string and will do stuff with it and will return a unit. Okay, so I can call the logger here. I can do like logger, like calling do on debug, and then I can also print something here. Debug and set. This is plain old debugging with print line. I'm pretty sure people are doing it. I also do it from time to time, so don't be ashamed of that. So this do on debug here complains because you're not passing the logger. So what do? We pass print line and we use that as a logger. Okay, so let's try to run it. Seems like it works. So yeah, we have the do something here. We have the calling on debug and set, then we print the shrug. And then just to make things a bit easier to understand, let's also print something at the end. Okay, so we have our print. Fantastic. So let's say that now, with the logger, I want to do something. I want to flush it because I want to make sure that when this do on debug runs, at the end the logger is clean, like everything is printed. So I will do a flush logger, and I will pass the logger, and I need to create this function. So I assume that I don't know, do something with the logger. This is just an example, but let's say that you have a more complex interface that will do something with the logger. So this code, as it is, it doesn't compile. It doesn't compile because you are passing the logger around. And if you inline it, this logger should be a variable because it should be passed inside another function, while inlining means text copying over the text. So it means that there will be text copied over here, and this is not a valid call of a function. So this logger should not be inlined. So to make this code compile, you need to add the not inline keyword to this lambda. So now let's put it on 2 lines to make them easy to see. So we have 2 lambda. The first one is this logger. We added the no inline because we don't want the inlining to happen for this, because we want to pass it around or even storing it as a variable. Like I can't do this. I can't store block inside a variable because block is inline. I will have to no inline also this. So let's see what the bytecode of this function do on debugger with one lambda that is not inline and the other that is inline look like. So as you can see, we now start to get complicated, but we have the main function with the if. Here we see that there is a if get on debug equal now is not null. And then we see that we have a flash logger call here with an instance, logger IV, and this logger IV is a function one. So here we have like an object creation, a function is created. So this is what the no inline will looks like. If I remove this, I also need to remove this, and I go to the compile. Everything is inlined. There is no instances. There are no instances. There is no variables that are being passed around. So I hope this sort of clarified the no inline. So okay, now the crossing line. The crossing line is the last one. That is a little bit more complicated, but not crazy much. So here we are printing. We have this shrug, right? This is a character. There is, like, if you have Unicode, you will see it. Is a kanji character. If you don't have Unicode or UTF-8 support, like, you will not see it. So let's say that you have a function, class, that helps you understand if kanji characters are supported. Okay, so you have a char util, and then you have inside a function is kanji supported. I actually don't know if this is kanji or any other ideogram. I'm really bad at that, but it's a Japanese symbol. Japanese people will forgive me for that. So you don't want to print this if, let's say, kanji is not supported. So what do you want to do? You want to do stuff like that. If so, let's create a char util. Char. You want to do if char util dot. So if it's not supported, you want to do this. You want to special char not supported and return. Okay, so let's try to run it. Okay, I set this kanji supported kanji to true. Let's set it to false, and let's see if that works. Yeah, it prints correctly. Okay, so in order to understand what I'm trying to achieve, I need another parameter. So in the do on debug, I need a times integer. That will be set to 10. So I want now the possibility to specify how many times this do on debug should execute. So this do on debug will get a logger to print logging. We'll get a parameter times that is equal to 10. So we'll allow to repeat the block 10 times, up to 10 times. And then we'll get a block. So I can use the repeat function. Repeat times. And then do stuff. And then maybe also do like this and then print it. Okay, so now all the pieces of the puzzle are here. What do we have? The bug function that runs 10 times, prints the shrug, and we do whatever. And then the main is over. So what's the problem here? So the problem is, let's say that there is a bug Okay, this char util function is not consistent. It's not always returning true. It's returning false. It's returning true for a certain amount of time and then failing. I don't know. So to simulate this this scenario, let's do like this. So I'm having a private counter that no one can see, and this is kanji supported will return true for the first 7 times, and then at a certain point it will break up. It will just say no, it's not supported anymore. Okay, so let's check the run. So we have do something, calling on the bug. That it's here. Let me zoom back a bit. Okay, so we can see all the code. Running time 0, 1, 2, 3, 4, 5, 6, 7. At the 7th, there is when I introduce this bug, let's call it like that, this return false. And then we have special char not supported and return. So what's the problem? The problem is that this return here basically broke everything. So I haven't just returned from this do on the bug. I actually returned from the main. And I never printed main is over. And I sort of broke all the behavior that other people wrote. And I'm outside of this do on the bug scope. This is called non-local control flow, and it's really bad. So the correct way to write this return would have been to do a labeled return, like this one. So what this will do is we will see the shrug till run number 6, and then from run number 7, special char not supported, blah, 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 and then main is over. This is our correct execution. The one before was not. What's the problem here? The problem is that the code got inlined, and this return let us get out from the main. So this is sort of bleeded out of this lambda because we have an inline function. So to prevent this, code from compiling, you can say that this block should be cross inline. Cross inline is a way to say that non-local control flow is not allowed. In this case, here will not compile and will tell us a return is not allowed here. Change it to return at do on the bug. So this scenario happens a lot if you are writing libraries or util functions that rely on and basically compose the lambda with others, or sort of like create execution around them. For example, here what I'm doing is that I'm actually repeating the function X times. So if you press the lambda around, if you manipulate that, you probably need this cross inline. Just so, I think it's important to know it, and it's also important to see, like when you go in the standard library, there are a lot of usage of that, and so now you know what it's used for. And with this, I'm done.
Great. Yeah,
awesome.
This is really awesome. Yeah, I think that was a good explanation of a lot of things, especially the inline and cross inline were things I like up there. Those are easy to get confused by. Yeah, so
yeah, literally. Like I spoke with a lot of people, and oh yeah, I remember I read the crossing line somewhere in an article, but I don't really know what it does. Yeah, I think it's like it's also crafting the example in a way that was understandable was not really easy. I hope it was clear for the majority.
Yeah, that's I think, well, it seems like people like it as well. I'm wondering, do we have any questions? Anyone have any questions for Nicola? Yeah, doesn't seem like that. So I also like to mention I like that you gave a warning about usage of the operator overloading. It's something that is easy to shoot yourself in the foot with.
Yeah, I think one use case that I found really useful for operator overloads is when you're working with graphics.
Yes.
Especially if you're doing like, I mean, Android custom views, not so much, but if you're doing like any sort of graphics programming, you have a lot of like vectors and points and special types that you might want to manipulate, and operator overloads there plays a nice role.
Yeah. And there is one example. Another example is to use the invoke operator on the inside the companion object. Then you can start creating builders in a really cool way. But yeah, so I think we're not getting any questions, and everybody seems to be happy.
Awesome.
And so yeah, so thanks everyone for joining us, and we'll do this again soon, I hope.
Don't be shy and reach out to us.
Yeah, thank you everyone. Bye.
Bye-bye.